So student, before we solve the questions, the numericals of refraction of light, let's go through the important formula. So the first formula is mu is equal to speed of light in vacuum by speed of light in medium. Next is lambda dash is equal to lambda upon mu. Then is delta minimum equals to 2I minus A. The fourth one that we will be using is mu, that means air mu medium is equal to real depth upon apparent depth, and shift is equal to real depth into 1 minus 1 upon A mu m, that means refractive index of the medium with respect to air. So basically with the help of these formulas we will be solving few questions to understand how are the different numericals that we get from refraction of light at plane surface, right? Let's start. So students, I have taken a question. Have a look at this question that it says the speed of light in air is 3 into 10 to the power 8 meter per second. We have to calculate the speed of light in glass, and refractive index of glass is given to us as 1.5. Let's see how to solve it. So speed of light in air is 3 into 10 power 8 meter per second. We can write that C equals to 3 into 10 to the power 8 meter per second, because we represent the speed of light in air as C. So I written C is equal to, and refractive index of glass is given, which means A mu G. So when we write A mu G, it means refractive index of glass with respect to air. That is given to us as 1.5. And we have to calculate the speed of light in glass. So what we have to calculate? V. That means V glass. Speed of light in glass is question mark, right? So the formula that we will use is A mu G. That means refractive index of glass is equal to speed of light in air or vacuum, speed of light in air upon speed of light in glass, right? So this is given to us. We can write 1.5 equals to speed of light in air is C, it's given to us, and this is V glass. So we will write 3 into 10 raised to the power 8 upon V glass, and now we can calculate V glass, that means velocity of light in glass is 3 into 10 to the power 8 upon 1.5, and just solve it. You will get 2 into 10 to the power 8 meter per second. So in this question, speed of light in air is given, refractive index of glass is given. We have to find out the speed of light in glass. Simple formula we are using, that refractive index is equal to speed of light in air by speed of light in glass. We put the value because refractive index was given, speed of light in air was given, and speed of light in glass can be calculated by just putting the values, and we are getting 2 into 10 to the power 8 meter per second, right? So let's see another question. Now look at this question. In this question, the speed of light in diamond is given to us, 1,25,000 kilometers per second, and we have to calculate the refractive index, and speed of light in air is also given, 3 into 10 power 8 meter per second. So how to solve? Let's see. So we will write that V diamond equals to 125,000 kilometers per second. Let's convert it to meter per second, because speed of light in air is given in meter per second. So 125,000 into 10 raised to the power 3 meters per second, and C, speed of light in air is given to us, 3 into 10 to the power 8 meters per second. So we have to calculate refractive index. So A mu diamond, refractive index of diamond, will be 3 into 10 to the power 8 upon 125,000 into 10 to the power 3, which means if you solve it, you will get 3 into 10 raised to the power 8 upon 125, we can write into 10 to the power 6, and if if you do 3 upon 125, you will get 0.024 into 10 to the power 2. Just solve it and you will get 2.4, which means we are getting refractive index of diamond as 2.4. So this was also a very simple question where speed of light in air is given, speed of light in diamond is given, and we just have to calculate the refractive index. So what formula we are using? That refractive index is equal to speed of light in air upon speed of light in diamond, and we are able to solve the question, right? Let's take another question and see. Okay, so have a look at this question. It says the refractive index of water with respect to air is given. So we write like this: A mu water, or we can write air mu water, is given to us as 4 upon 3. They are telling what is the refractive index of air with respect to water. We have to calculate water mu air. So look at refractive index of water with respect to air is 4 by 3. So what is the refractive index of air with respect to water? It is reciprocal of 1 upon, basically reciprocal of air mu water. So remember, whenever air mu water is given to you and you have to find out water mu air, you just do reciprocal and we can get water mu air. So reciprocal of air mu water is water mu air. So water mu air will be 1 upon air mu water, which is 1 upon 4 upon 3, which is 3 upon 4, and we are done. So refractive index of air with respect to water will be 3 upon 4, and this is our answer, right? So we generally get such type of questions from refractive indices, and there are few more types. Let's see another question that normally comes from this chapter. Let's have a look. Now let's have a look at this question. A ray of light whose wavelength is given 6600 angstrom. It suffers refraction from air to glass. So ray of light is coming from air to glass. They have given us the refractive index of glass as 3 upon 2, and we have to find out the wavelength of light in the glass. So when the ray of light is going from air to glass, the wavelength changes, we know. And what is the wavelength when it is in the glass? We have to find that. Let's see how to do it. So first we will write ray of light of wavelength 6600 angstrom. So which means lambda is 6600 angstrom. And taking A mu g, that is given to us as 3 upon 2. We have to find out the wavelength of light in the glass. So wavelength of light in the glass we represent by the letter lambda. So lambda dash. Lambda dash equals to, there is a formula which we have to remember, that lambda dash is equal to lambda by mu. And mu we can write A mu g, that means air mu glass. So this formula we have to remember, that whenever ray of light travels from one medium to another, we calculate the wavelength in the other medium is lambda dash, and that can be calculated as lambda by A mu g, where lambda is the wavelength in the first medium, and refractive index of the A mu g is the refractive index of the glass here. So lambda is given to us as 6600 angstrom, 6600, and refractive index is 3 upon 2. So we can just calculate it now. 6600 into 2 upon 3, which will give us 4400 angstrom, and this is our answer. So when the ray of light is traveling from air to glass, in air its wavelength was 6600 angstrom, and in glass we calculated the wavelength is coming 4400 angstrom, and this is what we were supposed to calculate, that what is the wavelength of light in glass, right? Let's take few more questions. Let's go to the next question, right? Now let's have a look at this question. They have given us refractive index of water is 4 by 3 and glass is 3 by 2, which means A mu W is 4 upon 3 and A mu G is 3 upon 2. We have to find out the refractive index of glass with respect to water. So we have to find out W mu G. So remember, there is a formula and I am coming to the formula. First see, A mu W, which is also called absolute refractive index of water, it is given to us as 4 upon 3. A mu G is given to us 3 upon 2. Now remember, W mu G, the formula is that it is equal to mu glass, which means air mu glass upon air mu water, or A mu. So which actually it means that A mu G upon A mu W. So W mu G formula is mu G upon mu W. So basically it means refractive index of glass upon refractive index of water. So let's put the value 3 upon 2 divided by 4 upon 3, which means 3 upon 2 into 3 upon 4, which will come as 9 upon 8, and 9 upon 8, if you calculate, you will get 1.125, and that's the refractive index of glass with respect to water. So this is our answer. So for doing this question, what we have to remember, that refractive index of glass with respect to water, the formula is that refractive index of glass with respect to air by refractive index of water with respect to air, and we can get in this manner, we can calculate in this manner, right? Let's solve some more questions to understand what other different kind of questions we get from this chapter in numericals. So let's see next. Look at this question. A ray of light incidents at an angle of incidence 48° on a prism, which means I equals to 48°. Angle of incidence is given 48°. So I is 48°. Of refracting angle 60°, which means angle of the prism A is given to us as 60°. It suffers minimum deviation, delta min. We have to calculate the angle of minimum deviation. This is question mark. So we have to remember the formula. What is the formula? That delta min is equal to 2I minus A. We have to remember this formula to calculate this question. So delta min we have to calculate. So 2 into I is given 48° minus A, which is given 60°. So we will get 96 minus 60, which will come as 36°. So delta min, that means minimum deviation, this angle is 36°, and just by putting the values in the formula, we have to remember the formula, delta min equals to 2I minus A. We can very easily calculate this question. So I is the angle of incidence, A is the angle of the prism, delta min is the angle of minimum deviation, and we can calculate angle of minimum deviation using the formula 2I minus A, right? Now let's go to some more questions. What are more different type of questions that we get in this chapter? Let's see. Now have a look at this question. This question is similar to the question that we did before, and we will use the same formula. Here what should be the angle of incidence? We have to calculate I is the question mark. For a ray of light which suffers minimum deviation, so minimum deviation is given to us as 36°, and it is an equilateral prism, which means A is equal to 60°. Now we have to calculate I, so we will use the same formula, delta min equals to 2I minus A, and delta min is given 36 is equal to 2I minus 60. Just solve it. 36 plus 60 is 2I, 96 is 2I, therefore I is coming 96 upon 2 is equal to 48°. And this question is similar to the previous question that we did. The values are given. Delta min formula we have to remember. Angle of the prism is given and delta min is given, angle of incidence is not given. Just put the values in the formula delta min is equal to 2i minus a and we can get the answer, we can solve it, right? So let's see some more type of questions that we can get from this chapter. Let's go to the next question. So this is a different type of question now. Here a water pond appears to be 3 meter deep. Appears to be. That means this is the apparent depth we say. So apparent depth is given 3 meters. Refractive index of water is 4/3, which means A mu W is 4/3. And we have to find the actual depth of the pond. That means we have to find out real depth. We have to find out. So what is the formula we will use? Now the formula is A mu W is equal to real depth upon apparent depth. Right? Simple formula. Now the values are given to us. So we can write 4/3 equals to real depth, I am writing for now RD upon 3. So we can very easily just calculate and we can get RD, that means real depth is equal to 4 meter. So we were supposed to calculate the actual depth of the pond and actual depth of the pond is coming as 4 meter. So the formula used is mu is equal to real depth upon apparent depth. And among the two quantities are given to us. The one real depth which is not given, we can easily calculate that, right? So let's take one or two more questions to see what more questions we get from this chapter. Let's go to the next question. Have a look at this question. A coin is placed at the bottom of a beaker containing water. Refractive index is given 4/3 at a depth of 16 centimeter. By what height the coin appears to be raised when seen from vertically above? Which means what? There's a beaker, the beaker contains water and just below the beaker a coin is kept and the depth of water in the beaker, it is 16 centimeter. By what height? So coin will appear to be raised because refraction will take place and coin will appear to be raised. So what is that, by what height the coin appears to be raised, we have to calculate. So there is a formula, that formula is shift. That the question is by what height the coin appears to be raised, that's called shift. So shift is equal to real depth into 1 minus 1 upon mu, the refractive index. So here A mu m, that means refractive index of the medium with respect to air. This formula we have to remember for solving such question. So shift we have to calculate. Look at real depth. So depth was given 16 centimeter, 16 into 1 minus 1 upon, and refractive index was given 4/3, which will become 16 into 1 minus 3/4, which means 16 into 1/4, which will come as 4 centimeter. That means by what height the coin appears to be raised. So coin will appear to be raised by 4 centimeter. So by what height the coin appears to be raised when seen from vertically above. And we can calculate that in this manner using this formula, and the answer will be, it will appear to be raised by 4 centimeter. So we can solve such questions using this formula of shift. Shift equals to real depth into 1 minus 1 upon A mu m. We can use this formula to calculate such questions. Let's take one last question similar to like this, and that mostly covers all the questions that come from this chapter. That means the numericals type that comes from this chapter. Okay. So let's take the last question, number 10. So have a look at this question, similar to the previous question. A postage stamp kept below a rectangular glass slab of refractive index 1.5. So mu is equal to 1.5. We are viewing it from vertically above it and it appears to be raised by 7 millimeter, which means shift is 7 millimeter. So whatever it appears to be raised, that is called the shift. So shift is 7 millimeter. We have to calculate the thickness of the glass slab. So which means we have to calculate the real depth. Thickness of the glass slab equals to real depth. We have to calculate this. So what is our formula? Our formula is shift equals to real depth into 1 minus 1 by mu. We will just put the values. Shift is 7. So 7 is equal to real depth. I am writing RD into 1 minus 1 by 1.5. So if we solve this, what do we get? Let's solve it. So we can write 7 equals to, so 7 equals to RD into 0.5 by 1.5. So which will give us 7 into 15 upon 5 equals to real depth. 5 3 times. So real depth is coming 21 millimeter because it was given in millimeter. So what we are getting, that is also in millimeter. And if we calculate it in centimeter, so just divide it by 10 and you will get 2.1 centimeter. It will appear, calculate the thickness of the glass slab. So thickness of the glass slab will come as 2.1 centimeter, and that's how we can solve this question. So these were all different type of questions that we get from refraction of light at plane surfaces. The questions are from the prism, from the glass slab, from refractive index, mostly that delta minimum from the prism. Mostly such questions we get. So I have tried to cover all such numericals. Hope you have found the video useful, and if you have found it, please like my video and please subscribe to my channel. Thank you so much for watching my video. Thank you. Bye bye.